Hello and welcome to another session in mathematics. In this session we'll be looking at logic. But before that, let us take a review of the previous lesson. Welcome back. In this session we'll be looking at the truth table. Okay, so let us quickly go to the business of the day, the truth table. Okay, I said here that the truthfulness and falsity of a statement is what we call what? The truth table. The truthfulness and falsity of a statement is what we call what? The truth table. I said just earlier that a statement will either be true or false, but not both. Okay, a statement cannot be true and at the same time be false. It's either it is true or it is false. Okay, so now the truthfulness and the falsity of a statement is what we call what? The truth table. Okay, now the truth value of a statement could be true or false. When a statement is true, we use capital letter T. When it is false, we use capital letter F. Okay, the table indicates the truth values of a compound statement. And the table has a number of columns and rows. It has columns and rows. And in the initial columns, the possible truth values of the constituent statement are written, while in the last column the truth value of the compound statement is written. Okay, the truth value of the compound statement is written what? In the last column. Okay, why the truth value of the constituent statements are written in the what? Initial columns. Okay, get that straight. The number of columns depends on the number of constituent statements and how involved their relationship are. Okay, the number of columns, let me say it again, depends on the number of what? Constituent statements and how involved are their relationships. Okay, and the number of rows in a truth table is determined on the basis of constituent statements. If the number of constituent statements is n, then the number of rows in the truth table would then be equal to 2 raised to power n. So assuming the number of constituent statements is 2, then the number of rows in the truth table would then be 2 raised to power 2, which is equal to what? 4. If the number of constituent statements is 4, then our number of rows will then be equal to 2 raised to power 4, which will give us what? 16 rows. Is that clear? So let us take example. Okay, we have a question here on the screen that said we should construct the table value of each of the connectives. We still remember what connectives are, right? We treated that in our last class. Connectives and or, not, and the rest of them. Okay, so the first connective we have is what we call the conjunction, which is and, right? Conjunction. And the first thing you need to note in this conjunction is that P and Q are true only when P and Q are true. Let me say that again. P intersection Q or P conjunction Q is true only when P and Q are true and false otherwise. So if we have our P to be equal to true and our Q is also true, then the statement is what? True. But if P is true and Q is false, then the statement is what? Is false, and so on and so forth. Do we understand? So let us take the example. I said let P and Q be two statements. Let P and Q be two statements. Here we have P here and here we have Q. Okay, and then let's take the inputs of P and Q to be the first one true, take here to be false, and here to be false. Okay, if Q is true then it means that P intersection Q is what? Is true. Do we understand now? By this condition, I told us here, note, P intersection Q is true only when P and Q are true. So we have P to be true and Q to be true. Then P intersection Q is equal to what? True. Okay, let's assume P is true, but Q is false. Then P intersection Q will then be what? False. Do we understand? Then if P is false and Q is truth, P intersection Q is also false. If P is false and then Q is also false, P intersection Q is also false. Do we understand now? This is how the conjunction works. Okay, let's look at the second one, which is this conjunction. Okay, here we are still working with P and Q, and I said that P disconjunction Q is false when both statements are false and true otherwise. If the both of them are false, then P disconjunction Q is what? Is false. Then otherwise, every other thing becomes what? True. Do we understand? So normally we have here to be T, false, and false. If here is T, then it means invariably that this is T. If here is false, this is also T. If here is T, this is also T. But if here is false, then the equation is what? Is false. He said it is false only when what? Both statements are false. So this is false, this is false. Then the answer here, the product here should be what? False. Apart from that, every other thing becomes what? True. Okay, let's look at negation. We have P. If we have here to be truth and here to be false, our answer is just the opposite of this. So if this is true, then this is false. If this is false, then this is true. Do you understand? That's just negation. Negation of P written as this is just the opposite of whatever value we have here. Okay, so let us take implication or condition. Okay, it said P implying Q is true except in the case when P is true and Q false. Did you get that? P implication Q is true except, mark the word except, in the case when P is true and Q is false. Okay, now every other thing here is true. So if we have here also to be the normal T, here to be T, F, and F. Now, and our Q is T, F, T, F. We are told that everything is true except when P is what? Is true. So here, P is true. Since P is true and Q also is true, then our answer is what? True. Because they said that everything is true except in the case where P is true and Q is false. So if these two things are not satisfied, then we cannot have a false. Okay, now here P is true and Q is what? Is false. So at this point we have our answer to be false because it satisfies the condition when P is true and Q false. Then apart from that, we have P to be false and Q to be T. Our answer is also what? T, because it does not satisfy the condition. And here we have our P to be F and we have our Q to be F. So our answer also will be what? Anybody? Our answer will also be T. Okay, the only condition that is applied here is when P is true and Q is false, then the answer is what? Is false. This is the point when P is T and Q is F. Okay, let us take the last connective. the last connective, which is by implication. By implication, we have to note here that P by implication Q is true if and only if P and Q have the same what? Truth value. If only they have the same truth value. Okay, let us start. This is our normal T and T. This is F and F. This is T. This is F. This is T, and this is F. Okay, now we have P implication F. So we need to remember the law of the implication. Okay, we need to remember the law of what? The implication or conditional. Okay, and what does the law say? It says that P implication Q, which is this, is all true except the point where P is true and Q is F. So apart from this level, every other thing here gives us what? True, true, true. Okay, so we have all this to be true apart from this. This is what? F. Do you understand? Then we now have Q implication what? P. For Q implication P, everything also will be true except the point where Q is F and P is truth. So here will be what? Truth. Here will be truth. Here will be false, and here will be what? Truth. Now P by implication Q is equal to P implication Q intersection Q intersection P. Okay, so for this we have T and T, and what would that give us? We have T. Remember, the intersection here is our conjunction. The law we use them in conjunction, and conjunction tells us that P intersection Q is true only when P and Q are true and false otherwise. So when P is true and Q is true, then the answer is what? Is true. When P is false and Q is true, then the answer is false. When P is true and Q is false, it's also false. When P is true and Q is true, then we have our answer to be what? True. So we have T, F, F, T. Okay, this is just how it works when it comes to what? The truth table. Okay, so far we've been able to cover truth table and logic, logical reasoning, and we've been able to give examples using the connectives. Okay, to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. We'll stop here for today. So do well to use the lesson note on the platform for better information on the topic we've just discussed today, and feel free to drop your comments or questions on the comment section. So till we meet again in our next class, stay safe and bye.